So 1.8 part 1 was absolute value equations. 1.8 part 2 is absolute value inequalities. So we're going to have the greater than, less than signs. So just like when we had inequalities on the last test, we have the same rules here. If it is just a less than or greater than sign with no equal to, you have an open circle at those key numbers. If you have a less than or equal to or greater than or equal to, it's a closed circle. And then notice here how we're either going to be shading in between our 2 points. When we shade in between and we just have one part of the graph, our inequalities are just in one line together. We have one inequality. But if we have two parts of the graph and we're shading outside, we have two parts to our inequality. And then same thing that we were doing before with our inequalities. When we write it in interval notation, if we just have one piece of our graph, we're just going to have one part of our interval notation. If we have two pieces, so if we wrote our interval notation for like the third piece here, it would go from negative infinity to negative c. It's an open circle here, so it'd be a parentheses. We put a u for our union, and then it continues again at c and goes to infinity. So we're going to practice this with our examples with numbers. On the web assign, it doesn't make you graph these, but it asks for the interval notation. So you have to kind of graph them in your head to figure out if you're going to shade in between or outside. So let's look at our first example at the top. When solving absolute value inequalities, the first step is to isolate the absolute value. Second step, just like when we had absolute value equations, we want to split it into two. So in our first example, our absolute value is already isolated. It's already by itself. Next step is we want to split it into two inequalities. So the first one's going to stay exactly the same how it is here, but we're going to get rid of our absolute values. So we have x minus 5 is less than 2. For our second absolute value, for our second inequality, the absolute value part goes away. The left side stays the same, so we have x minus 5. But we flip the inequality, so we now make it greater than, and we change the sign and make it negative of the number on the other side. So we flip the inequality and make the number negative. So now let's solve our two inequalities that we have here. For the first one, what do I do to solve for x? Add 5 to both sides. We have x is less than 7. In the second one, we're going to do the same thing. We add 5 to both sides. So x is greater than 3. So let's put those on our number line. Which number is smaller? 3. So I'm going to put 3 and 7. Make sure the smaller number goes first. A lot of people made that mistake on the last test. Smaller number goes first. Do I have an open circle at these points or closed circle? Open circle because it's just a less than or greater than sign. There's no equal to, so we have an open circle. Now we're going to figure out if we're going to shade in between these 2 points or outside the 2 points. So we can pick a number in between just to test. What's the number in between 3 and 7?
0.
Is 0 in between 3 and 7?
No, number 5.
5 is in between. You could have said 4, 5, or 6. If you wanted to, you could test the number outside. Just make sure you're paying attention to where the number is that you're going to test. So here we have 5 minus 5, and the absolute value is less than 2. What's the absolute value of 0?
0.
So is 0 less than 2? So do we shade where 5 is? Yes, since it's true, we shade where the number we plugged in is. So now for our inequality part, we write them together. Since we just have one piece of the graph, we're going to write those two pieces together. So it would be 3 is less than x, which is less than 7. We put our two inequalities together. Always start with the smaller number. And then for our interval notation, it's just going to be one interval. If it's an open circle, do I have a bracket or parentheses? Parentheses, 3, and our graph ends at 7 with parentheses. So these would be the 3 parts to our answer. On WebAssign, it is only looking for the interval notation, but on the quiz, you'll have to graph it too. Any questions there? Good with that? Let's do number 2. So 2, our absolute value is already isolated, so we can go ahead and split it up. The first inequality is going to stay exactly the same, so we have x is less than or equal to 5. The next one, we flip the sign, so we have x is what? Greater than or equal to what? Negative 5. So you flip the inequality and change the sign of the number. You have to do both. These are actually both already solved for us, so we can go ahead and put them on our number line. Which one's going to go first? Negative 5. That's our smaller number. And do I have an open circle or closed circle? Closed circle, because it is less than or equal to. So put a closed circle and a closed circle. Now what's the number in between negative 5 and 5? 0. So let's plug in 0 and test and see if it works. Is 0 less than or equal to 5? Is 0 less than 5? Yes. So it works. So where am I going to shade? In between. So since we have one part of our graph, we can put our inequalities together as one inequality. So we have negative 5 is less than or equal to x, which is less than or equal to 5. Bracket or parentheses? Brackets. Awesome. Negative 5 comma 5 with brackets. Yes, for your interval notation, your smaller number has to go first. Let's do number 2. Our absolute value is already isolated, so we're good. We can go ahead and separate it. So I have 2x is less than 20. What's my other inequality going to be? Awesome. 2x is greater than or equal to negative 20. Bless you. So let's solve. What would I do to solve for x? Divide by 2. So x is less than or equal to 10. Same thing in our other one. We're going to divide by 2. So x is greater than or equal to negative 10. So let's put them on a number line. Which one's going to go first? Negative 10. The smaller number always goes to the left. Do I have an open or closed circle at the points? Closed, because it's less than or equal to and greater than or equal to. So closed circle. What's the number in between negative 10 and 10? 0. Let's plug in 0 and see if it works. 2 times 0 is still 0. So is 0 less than or equal to 20? Yes. So where am I going to shade? In the middle, where 0 is. So when I write my inequalities together, I start with the smaller number. So negative 10 is less than or equal to x, which is less than or equal to positive 10. And then for my interval notation, would I start with a bracket or parentheses? Bracket. What number? Negative 10. The smaller number goes first, and then it ends at 10 with a bracket. Let's do number 3. So my absolute value is already isolated, so we can go ahead and drop it and keep our first inequality exactly the same. So 2x is greater than 7. What's the other one going to be? 2x is less than negative 7. Perfect. So when we solve for x, I'm going to divide by 2. So x is greater than 7 over 2. Same thing with our other one. We're going to divide by 2. So x is less than negative 7 over 2. Put them on our number line. Which one goes first? negative 7 over 2 because that one is smaller. Do I have an open or closed circle at these points? It's going to be an open circle because we have just a greater than and just a less than. So open circle, open circle. What's the number in between negative 7 over 2 and positive 7 over 2? 0. So let's plug in 0. 2 times 0 is 0. Is 0 greater than 7? No. So where am I going to shade here? Outside. So here we have 2 parts to our graph. So our inequalities stay separate. We have x is less than negative 7 over 2 or x is greater than 7 over 2. So when you have 2 parts of the graph, you're going to have 2 inequalities in your answer. You can't write them together.
You don't put the U thing?
For our interval notation, we put the U thing. So our interval notation, we're also going to have 2 parts. What's our smallest number here? What's the arrow to the left pointing to? Negative infinity. So we're going to start with negative infinity. Remember, infinity and negative infinity always get parentheses. Where does our graph end on the left side? Negative 7 over 2. That piece ends at negative 7 over 2. Does that get a bracket or parentheses? Parentheses, because it's an open circle. Since we have a gap in our graph, we need to put the U for a union. Where does our graph start back up again? 7 over 2, again with a parentheses, because it's an open circle. And then where does our graph go to? Infinity. So this would be our interval notation, our inequality, and then our graph. So when you have 2 parts to your graph, 2 pieces here, you're going to have 2 pieces to your interval notation. And you're also going to have 2 pieces to your inequality. Let's do number 9. So step 1, we said is what? Isolate the absolute value. So I'm going to add 3 first. Perfect. So 4 times the absolute value of x plus 2 is less than 16. Then we divide by 4. Awesome. Since 4 is being multiplied to the absolute value, we have to divide to get rid of it. So we have the absolute value of x plus 2 is less than 4. So the first one stays exactly the same. We have x plus 2 is less than 4. What's our second inequality going to be? Is greater than negative 4. Perfect. So we flip the inequality sign and change the numbers to be negative. So we have our 2 inequalities here that we're going to solve. So in the first one, what would I do to solve for x? Subtract 2, so x is less than 2. Second one, we do the same thing, subtract 2, so x is greater than negative 6. Which number am I going to write first on my number line? Negative 6. Do I have an open or closed circle at these numbers? Open circles. What's the number in between negative 6 and 2 that I can test? 0. Awesome. So let's plug in 0 into the original. So we have 4 times the absolute value of 0 plus 2 would be 2, which would be 8 minus 3. What's 8 minus 3? 5. Is 5 less than 13? Yes. So that is true. So where am I going to shade? In the middle. So since I'm shading in the middle, I'm going to have 1 inequality. So I start with negative 6 is less than x, which is less than 2. I'm also going to have 1 interval notation. Do I have a bracket or parentheses for my interval notation? Parentheses, negative 6 to 2, parentheses. So for 11, we want to isolate the absolute value. So what would we move first? We're going to subtract 5. So 7 times the absolute value of x plus 2 is greater than negative 1. What do we do next? divide by 7. Well, let's think about it. So we have the absolute value of x plus 2 is greater than negative 1 over 7. Absolute value does what to a number?
Makes it positive.
Makes it positive. So give me a positive number, any positive number. 5. Is 5 greater than negative 1 over 7?
Yeah.
Yeah, that's true. Give me another positive number. 1. Is 1 greater than negative 1 over 7?
Yeah.
Yeah, that's true too. So any number that we plug in here to x, it's going to change to be positive. Any positive number works here. So what do you think our answer is? All real solutions are infinitely many solutions. So we'd say infinitely many solutions. How do you think we write that as an interval notation? Well, what's the smallest number that it could be? Negative infinity to what? Positive infinity.
When we took the equations, like part 1, if it's negative, it's
Right, because your absolute value can't equal a negative.
okay.
But here we're saying that it's greater than a negative number, which any number you plug in will be greater than a negative number.
And if it was less than, it wouldn't have worked.
I don't think you're going to get one of those.
Okay. You got it.
All right, 2 more. Let's look at number 12. So 12, we have a compound inequality. You're not going to have one like this on the homework or on the quiz. So I would say don't stress about it, but we're just going to talk about it for a second. So when you have a compound inequality, we can split it up into 2 inequalities. So the first one's going to be 1 is less than or equal to the absolute value of x. My other inequality is going to be the right side. So that'll be the absolute value of x is less than or equal to 4. Now this is just like what we did before, but we have 2 parts here. So each one I have to split up. So the first one in blue, I have 1 is less than or equal to x. So I keep it exactly the same because my absolute value is already isolated there. What do you think my other inequality is going to be when I split this? Awesome. Negative 1 is greater than or equal to x. So these are technically already solved because we don't have anything else to do. So we've got 2 answers there. For the next one, I have x is less than or equal to 4. What's my other one going to be? X is greater than or equal to negative 4. Let's put these on a number line real quick just to see what it looks like. What number am I going to start with? What number goes furthest to the left? Negative 4, and then? Negative 1, then 1, and then 4. Do I have an open or closed circle at these points? Closed circle because they are all that or equal to in our inequality. And then when we start to graph these, you would just plug in a number in between each set to see what works. But you're not going to have to graph these. You won't even have one of these on the quiz or the homework. But just a good thing to think about in case you see it on the SAT or something. Any questions here? All right, last one, 14. So step 1 is to isolate the absolute value. What would we need to do to isolate the absolute value here? Awesome. Multiply it to the other side. So we're going to multiply both sides by the absolute value of 2x minus 3. So times the absolute value of 2x minus 3. So it cancels out on the left side. So what am I left with on the left side? On the left side. 1. So 1 is less than or equal to, the right side is 5 times 2x minus 3. Awesome. Our absolute value isn't isolated yet. We still need to divide 5 to move it to the other side. No. Yes. All right. So now our absolute value is isolated. What would we do next?
Make it negative and flip the sign.
Awesome. let's split it into 2. So we have 1 over 5 is less than or equal to 2x minus 3. The other one's going to be what? Negative 1 over 5 is greater than or equal to 2x minus 3. Now let's solve both of these. It's a good one to practice because we have fractions. So I'm going to add 3 to both sides. I'm going to write this on the side here so we have more space. So I have 1 over 5 plus 3. How do I add a fraction and a whole number? I need a common denominator. So I'm going to multiply this by 5 over 5 to make it 15 over 5. And then we add the numerators. We get 16 over 5 is less than or equal to 2x. What would we do next? Divide by 2. Oh no, what do I do when I have a fraction in a fraction? Change, flip, or multiply by the reciprocal. Same thing. So we keep the top, change to multiplication, and flip the denominator to be 1/2. Multiplying by the reciprocal is like the mathematic version of keep, change, flip. You're doing the same thing. When we multiply fractions, multiply straight across. So we get 16 over 10. Can I simplify 16 over 10? Yes. To what? 8 over 5. So 8 over 5 is less than or equal to x. Let's do the other half. We're going to do the same thing. So we subtract or add 3 to both sides. So we have negative 1 over 5 plus 3 over 1, which we can make to 15 over 5. Be careful with the signs here. We have negative 1 plus 15, which would be 14 over 5, is greater than or equal to 2x. What do I do next? Multiply by the reciprocal. So we're technically dividing by 2, which is the same thing as multiplying by 1/2. So when we multiply fractions, we multiply straight across. So we have 14 over 10 is greater than or equal to x. Can I simplify 14 over 10? Yeah. 7 over 5. Let's put these on our number line. Which one's going to go to the left? Which one's smaller? 7 over 5. Do I have an open or closed circle? Closed circle. And then let's pick a number to test to see if we're going to shade in between or outside. Well, in between these two numbers, we only have fractions. So let's maybe just pick a number outside. What's a number smaller than 7 over 5? 0. Perfect choice. Let's plug it into the original. So we have 1 over the absolute value of 2 times 0 minus 3 is less than or equal to 5. So 1 over the absolute value of negative 3. What's the absolute value of negative 3? 3. So 1/3 is less than or equal to 5. That is true. 1/3 is less than 5. So where am I going to shade? Outside. Lucas.
Didn't you get to add the negative 14? Wouldn't it be negative 14 over 10?
All right, last step here. Let's write our interval notation. So our arrow points in the left direction to what? Negative infinity. So our interval notation starts at negative infinity and goes to what? 7 over 5. Bracket or parentheses? Bracket. Then we put a union because we've got 2 parts. Where does it pick up again? Bracket 8 over 5 and goes to infinity parentheses. And then since our graph has 2 parts, our inequality is going to have 2 parts too. So we'd say x is less than or equal to 7 over 5, or x is greater than or equal to 8 over 5. So on the web assign, it's only asking for the interval notations for the homework, for this homework. But on the test, you'll have to write the inequality, the graph, and the interval notation, just like you did on the test.